Hello, everyone. You're probably wondering who I am. It's not enough that we're all here for a machine learning competition. So, I am text-to-speech technology. I will be representing my friend's team downloading today to present the result of the Thailand Machine Learning for Chemistry competition, or TMLCC. Let's with an overview of what we've done. I'll walk you through cleaning the data first. Then we'll go through feature extraction shortly. Finally, we will about all models the end. Okay, here's how we felt when we saw the data. It was like, wait, what? Before we do anything, we need to rapidly clean the data. So, during the pretest, we dropped the trained data by about 1,000 rows. It was really difficult to complete. Next, we will about the feature extraction. What features do we need for the model? First, in the CIF file, what further can we do? As a result, the missing surface area, void fraction, void volume were reconstructed in the trained data. We also extracted further information about the linkers as canonical smiles. Finally, we compute porosity using the CIF files. Second, all linkers are transformed to Coulomb matrices. Their 3 to 10 eigenvectors are determined. The CIF files' functional groups were enumerated. Later, the metal percentage was computed based on the total number of atoms. Third, for the categorical data, including linker types topology, those were encoded in the form of zerosones, or the one-hot form. Here is the summary of our features including the created features. If anyone is interested, these are the features that we utilized the supercomputer to calculate implemented. Thank you very much for the resources provided by the National Supercomputing Center Singapore. The most exciting part of this competition is here. The model. To begin, we used a tool called lazy prediction to save time while experimenting with Wedias regression techniques. We also tried to perform the regression using a neural network. As a consequence, LightGB MCAT offered the most accurate prediction. Then we tried to find the most important feature out of all of them. Here is the outcome. We also discovered 8 more features that have an influence on our regression model. Here is another technique that was inspired from the form of the molecules. As we can see, the molecule can be seen as node edge. From our data, it was not reasonable to use a 2D convolutional network without extracting the 2D data. So we used the canonical smiles to find the molecular fingerprint, adjacency matrix, molecular size, and train the graph neural network model, or GNN. The result was really good. Next technique is graph convolutional networks, or GCN. Like GNN, we extracted the features out of canonical smiles, used the convolutional neural networks to train to model in order to receive the information about neighborhood relationship. Last but not least, the molecular attention transformers, which were inspired by the previous 2 approaches, were also tested in the data. Because this model includes an attention layer that captures the locational region, uses position-wise feed forward to highlight the area of the molecule that is critical to the prediction. Here is the summary of all model training. We use both generated features to the boosting technique for finding the important features, and then recode the GNN, GCN, mat to receive the shape of our data hope for the prediction. Unfortunately, an unpredictable event happened. The model couldn't make it on time. So, the plan is changed, lest the model is already learned. Just use the output of the training model zone of the features in LightGB MCAT then. Here was the submission. I think we are the best problem solvers now. Thank you everyone, especially the organizer for this event. It was fun.